Hello girls, let's discuss about the limits and differentiation in today's class. Okay, say for example, if there is a question like this, limit x tends to 5, x square minus 25 by x minus 5. Okay, so here x tends to 5 means x is approaching close to 5, but it's not exactly equal to 5. In such case, how to solve this one? So if you put x in, if you put 5 in place of x, it's going to give you 25 minus 25. 5 square is 25. 5 minus 5 is 0. Okay, so 25 minus 25 is 0, 5 minus 5 is 0. 0 by 0 is an undefined form. Okay, the reason why it is undefined form is 0 by 0 satisfies any value that you put. You take any value, for example 5. This is holding good because 0 multiplied with 5 is going to give you 0. For example, if you put 15, 15 multiplied with 0, that gives you 0. If you put minus 15, even that this is going to holds good. Minus 15 times 0 is 0 because there is no difference between minus 0 and 0. That is why it is undefined form. Sorry, it's an undefined form. So in such case, what you have to do is find the factors of this one, of a numerator. Okay, so what are the factors of x square minus 25?
X plus 5, x minus 5.
X plus 5, because this is can be written as a square minus b square, which is whose factors are a plus b into a minus b. In this case, x is a is x and b is 5. So x tends to 5, x minus 5, x minus 5. Okay, x plus 5 multiplied with x minus 5. A plus b into a minus b. A square, which is x square, b square, 25. A square minus b square. So here in the denominator, we're going to have x minus 5. So what can we cancel here? X minus 5 and x minus 5 gets cancelled and you are left with x plus 5. Now you replace x with 5. So if you put x as 5 plus 5, which gives you the answer of 10. So this is the answer for this one. Okay, when limit x tends to 5, x square minus 25 by x minus 5, the answer is 10. Okay, this is how you need to solve. Okay, you need to try to figure out the factors of either numerator or denominator such a way that one of them gets cancelled and gives some meaningful value when you replace x with 5. Okay, so in this case 10 is a fixed. The 10 cannot be 5. 10 is a defined form. Okay, 10 cannot be minus 10. 10 cannot be 0. Okay, 10 is 10. 10 as it's a distinct value, whereas 0 by 0 does not have any value. It's very difficult to define it. So that is why it is called undefined form. What are the other forms of undefined forms?
Infinite over infinite.
Infinite over infinite is also undefined form. Very good. Okay, so let's pick up a couple of more questions and see if we can solve them or not. Okay, there are certain questions which are very much straightforward. Limit x tends to 3x square minus 2, limit x tends to 2. Limit x tends to 2, 3x square minus 2. In this case, what can we do? If you put x as 2, which is going to give you some definite value. Okay, so what do we get when you put x as 2? 3 into 2 square, 3 multiplied with 2 square minus 2. What is this one? 10. No?
No, full is 10.
No, full is 10, yeah.
10.
So 3 multiplied with 4, which is 12,
12
minus 2, which is 10. Okay, so you can straight away put it here because when you replace x with 2, you're not getting undefined form. In such case, we can straight away replace x with 2. Okay, let's move on to differentiation. The differentiation we discussed in the previous videos. The differentiation, for example, y is equal to x to the power of n. The differentiation of this one is going to be with respect to x. That's very important. Okay, when we are pronouncing, you're differentiating the function y with respect to x. Okay, dy by dx. The formula for this one, if it is x to the power of n, if y is x to the power of n, the formula for this one is going to be n into x to the power of n minus 1. Okay, the power comes as a multiplier and x power is reduced by 1. Okay, the power coming as a multiplier, x power is reduced by 1. Okay, that is the formula. Okay, you also have to make a note that there is a lot of difference between this one and this one, because here the power is the base and here the power is at the power. Okay, the formula varies. Okay, here the answer is going to be something like in logarithmic form, which I need to check in the book. But for x to the power of n, this is the formula, n into x power n minus 1. Okay, for example, f of x is equal to x to the power of minus 5. So let's do the differentiation of f of x with respect to x. Okay, you can say y is equal to x to the power of n or f of x. Both are same. Okay, it's a function of x. F of x is equal to x to the power of minus 5. So when you differentiate it with respect to x, what are we differentiating?
X.
No.
X to the power of n.
What are we differentiating here? We are differentiating function x, f of x,
F of x.
with respect to
X.
with respect to x. Okay, so what is the answer?
Answer is minus 5 times x to the power of minus 5 minus 1.
Minus 5 minus 1. Okay, the power is reduced by 1. If you reduce this one, what do you get?
Minus 6.
Minus 6. Okay, this is how we need to do it. Okay, for example, y is equal to x to the power of 2 by 3. So what is the differentiation of it with respect to x? dy by dx?
2 by 3 x to the power of
2 by 3 x to the power is reduced by 1. 2 by 3 minus 1. What do we get?
1 by 3.
Minus 1 by 3.
Okay.
Isn't it? 2 by 3 minus 1. You'll get minus 1 by 3. Is that true? Yeah, minus 1 by 3. Which can also be written as 2 by 3. How can we write this one? What is our way of writing?
Minus 1 by 3 times x.
Minus?
Minus 1 by 3. Oh no,
No,
square,
you don't. Why are you
a root square a root of x.
These are basics of powers and indices. Okay, square root of?
No, it's like minus 1 by 3 root x.
No. X to the power of minus n can be written as 1 by x to the power of n. Is that true or not?
1 by x to the power of 1 by 3.
Yeah, 1 by x power 1 by 3. Okay, x power 1 by 3 can be written as cube root of x. Is that true or not?
Yeah.
Okay,
Yeah.
x power.
So that it is minus 3 root.
Okay, how can we write this one? How can we write this one?
Of I by 3
No.
root x.
Fifth root of x cube. Okay,
How?
see the numerator here goes here. 1 is here, 1 is going here. Okay, whatever is the denominator is going under the root. Okay, so here it is a cubed root of x. Here it is fifth root of x cube. Okay, again these two. What is x to the power of minus n?
1 by x to the power of n.
Okay, what is x to the power of 1 by 3?
Cube root of x.
Cubed root of x. What is x to the power of 2 by 5?
Fifth root of x squared.
Okay, fine. Yeah. Okay, so how can we write this one here? There are two rules that we have to apply. One, it is having a negative power. In such case, you can say 1 by x to the power of 1 by 3.
No, or I can say minus 3 root x.
No.
Yeah, we can.
Cube root of x to the power of minus 1. Cube root of x to the power of minus 1.
Cube root of x to the power of minus 1, yeah. But the purpose is we should not have a negative powers, we should not have a fractional powers.
Okay.
Okay, so if you leave it here, that is fine. But sometimes if it is a multiple choice, you'll be given an answer which is not matching with this one. So in such case, you have to see what are the different ways of writing this one. Okay, this is having a fractional power, this is having a negative power, negative fractional power. We wanted to get rid of negative things, we want to get rid of a fractional power. So in such case, this is how you have to do. How can we write this one? X to the power of 1 by 3?
Oh yeah. 3 root x cubed root of x.
Cube root of x. Okay.
Yeah.
Okay.
1 by cube root of.
Cube root of x. Okay. So this is also another answer. Either this one or this one. Anything is same. Or this is also valid. Okay.
Oh no.
But it should be in your fingertips to move from one form to other form at ease. Coming. Yeah.
Yeah, it's like it is also can be written as this, right? Yeah, and then minus will come there, and then x 3, like that.
Minus 3. Okay. Maybe, but usually under root we don't put a negative numbers. I've never seen anywhere people mentioning a negative numbers under root. Okay, minus 3th root of x, minus 3rd root of x, I have not seen anywhere. Minus 5th root of x, I have not seen anywhere. Okay, yeah. Okay, now tell me, x to the power of 1 by 3, how can we write?
Cube root of x.
X to the power of 2 by 5.
5th root of x squared.
Yeah. Okay, so these are the different ways of how to differentiate x having some power. Okay, having some power, x having a power. Okay, there is a difference between this one and x having a power. Okay, now let's pick. What is the differentiation of x with respect to x? What is the differentiation of x? 1. Because in this case, x is having a power 1. So dy by dx is going to be, the power comes as a multiplier 1, and x power is reduced by 1. When you reduce 1 by 1, how much you get? 0. X power 0. What is x power 0? 1. 1 multiplied with 1, you will get 1. Okay, so if you are differentiating any variable with respect to that variable, you will get 1. Okay, what is the variable here? X is the variable. You are differentiating x with respect to x. You got 1. Okay, okay. Alright, so I'm going to have another function y is equal to 5. I want to differentiate this with respect to x. What do we get? 0. Okay, how can we write in terms of x? 5 in terms of x?
I by x to the power of 0.
Is it? Okay. Okay, so there is an x hiding here. How is it hidden? 5 multiplied with x to the power of 0. Y can be written as 5x to the power of 5 multiplied with x to the power of 0. Okay. So if there is any such constant multiplier here, you can bring it. While you are differentiating, you can keep this aside, like you can keep it as it is, and just differentiate this one.
0 times x to the power.
0 times x power 0 minus 1. This is 0 times x power. So because we have here in this whole multiplication, everything becomes 0. Everything becomes 0. So dy by dx, what is this here in this case?
0.
Okay, what is this? Whose differentiation is 0?
5.
With respect to what?
X.
For example.
Or it can be a constant.
Yeah, for that matter, the differentiation of any constant is 0 with respect to x. Okay? Constant is a constant, like it is not changing. When there is no rate of change, the differentiation is 0. Okay? For example, y is equal to 5. How is this going to look like?
It's like
say for example, if it is 5 here, this is going to be straight line. There is no change. It is very much stable, and
slope
is 0. Slope is 0. Okay, the differentiation of any function represents its slope. Okay.
Yeah.
All right. There is also called a chain rule. So for example, dy by dx can be written as dy by du multiplied with du by dx. Okay, the easier way to remember is du and du gets cancelled and you eventually get dy by dx. Okay, you will eventually get dy by dx. For example, let's take a few examples and see how when to apply this kind of a chain rule. Okay, say you have y is equal to 3x plus 2 whole to the power of 5. How do we differentiate it?
Yes.
Okay, before we come to this chain rule, let's pick up one more complex.
Still differentiate the inner thing and then do
Yeah.
the
Exactly, yeah. Okay, so let's differentiate this one with we'll talk about this one a bit later. Dy by dx. What is dy by dx here? Because this is a summation, right? This is separate and this is separate. 5 times
2 times x to the power of 1.
X to the power of 1 plus
2 times x
2 times
1 2
1
2 1 times x
1 times x power
1
no
minus
0.
0.
What is power here? 1. When you reduce by 1, how much you get?
0.
0. Okay, 2 times 1 times 1 I didn't keep here because everything multiplied with 1 you'll get the same answer. Okay, so what is the answer here? 10
10x
plus 2. Okay, so this is the differentiation. What does this represent? This represents some nonlinear graph. Okay,
Square is there.
the slope of this one
At
is representing a straight line. The slope of this one is representing a straight line here. Okay, that means the slope is not constant. This is non-linear graph. Maybe something like this may look like this one.
Yeah.
The slope is varying at every different point.
Yeah.
Okay, at every different point. So the slope is also having x in it. So that means it is varying from as you move on the x-axis. Okay, the slope here is different. 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 Slope here is different. Okay. So I'm telling you a point. I'm giving you a point, and I'm telling you a slope. When one point is given, is it possible to find a slope?
No.
No. What is the slope formula? What is the traditional slope formula?
I equal to mx plus c.
No. That is a straight line equation in a
Y2
slope
minus
intercept
y1
form.
x2
y2 minus y1 by x2 minus x1. What is y2, y1? What is x2, x1? Those represents the 2 points.
Coordinate points.
Yeah, when the 2 points are given, that is the traditional formula to find the slope connecting those 2 lines. Okay, here I'm telling you a point and I'm telling you a slope. Is this possible to find the slope like this? When one point is given?
No.
It is not possible. But what I mean slope at a particular point is you take the shortest length around that point. Just as infinitesimally small. This is called infinitesimally small. Remember this word, it's very important. And if you're studying maths in higher classes, then this word is often referred infinitesimally small. You cut this point in a small slice, smallest slice, as small as possible. Okay, cut the slice and find the slope between these 2 points. Okay.
So it will be the same.
It will, yeah. When you cut it like an infinitesimally small slice, the slope between those 2 points is represented by this one.
Yeah. But how did you get the point?
So I'm saying a point slope at this point.
X.
What I mean at that point is infinitesimally small slice is considered around that point.
Where is the point in the equation?
This is a point. For example,
Is that
here.
not the slope? Is that not the slope?
Say for example, I'm saying a slope here. So that means a line is drawn here. What is the slope here? We'll get by putting x value, for example, here x is equal to minus 3. You keep the value of x as minus 3 and you'll get the slope of this point.
Okay.
Okay, for example, if you want to find the slope here,
So
which
you
is
have to
3.
say. So basically, you mean to say that 5x squared plus 2x is the equation of the curve.
Equation of the curve,
Oh,
and this is the equation of the slope line.
okay.
Okay, slope line. The slope also contains x in it because it is not having a constant slope. Here you will get a slope something. Here you will get a slope this term because you are replacing x. Here you are replacing x as 3, and here you are replacing x as 5. Like that. Okay, the slope is not a constant, it is varying. It is varying as you move in the x direction. That is why x is also that is why slope is also having x in it. For example, if you take an equation y is equal to 3x plus 2, let's differentiate it. What is differentiation with respect to x? dy by dx
3 times
3 times
1
1 plus
0.
0, which is
3.
3. Okay, so what is the slope of this function?
3.
3. Okay, how can you draw this line given equation? Is this a straight line or a
Straight.
non-linear line? It's a straight line. So
C is
y-intercept is 2 and the slope is having a positive slope. That means it rises as you move from left to right. This is x-axis. This is y-axis. Okay, so this is the slope. So the slope of this line is constant.
Yeah.
Is this changing the slope?
Because
it is a
the
straight line.
slope is 3,
Yeah,
right?
because the
So
slope
like-
is 3.
Yeah.
The slope of this line is constant. That means you pick the point. Pick the point here,
Yeah,
pick the
yeah,
point
it
here,
will
pick
be
the
the
point here,
same.
pick the point here. Or pick any 2 points on the line.
Yeah.
Any 2 points on the line. Okay, but whereas in the previous example, you cannot pick 2 points. Because
slope
what do you put
changes.
as x if you pick 2 points? Previous example, I'm analyzing this one. Okay, hope you are clear. The slope is 3, which is fixed. Because it is a straight line, the slope is fixed. Whereas in the previous example, I forgot what I took, but I am taking some other quadratic function. 3x. Okay, so what is dy by dx? 2 times x power 1 plus 3, which is 4x plus 3. Slope is 4x plus 3. So what is the given function? 2x square plus 3x, which may be looking like this one. Okay, which I am giving some rough sketch of this function. What is the slope of 4x plus 3? So you cannot take 2 points here. I cannot take 2 points here and find the slope because why? You tell me.
Because slope changes every time.
Every point, yeah. So what do you keep x here? Here it is 2, here it is 3. What do you keep as x here? You cannot keep any point.
Yeah.
You can neither keep 2 nor keep 2 nor keep 3.
Yeah.
That is why you pick only one point and try to find out the
If you
slope.
pick 2 and put 2 in place of x, you get the slope of that point.
The slope when x is equal to 2. When you put x as 3, when you get the slope when x is 3. Okay, but whereas in the straight line, you pick a point or pick any 2 points, you'll always get the same slope. Because the slope is constant, it is not changing. Okay, this is beautiful. If you really understand and intercept in terms of the graphs, then it's damn easy to crack. Okay. Okay, so those are the kinds of differentiations, but imagine a given function is like this. This is a binomial expansion. How do we expand this one? NC0,
Yeah.
x to the power of n
Pascal triangle.
plus a Pascal triangle is one way, but if it is power is too big, you need to apply the binomial expansion formula, which is NC0 x to the power of n plus NC1 x to the power of n minus 1 y to the power of 1 plus NC2 x to the power of n minus 2 y to the power of 2 plus dash 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 NCR x to the power of n minus r y to the power of r plus dash 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 NCN y to the power of n. Okay, that's how binomial expansion is. Okay, so this is also binomial expansion because there are 2 nomials. What are those nomials? 3x is one term, one nomial,
And
2 is another one, and we are 2 nomials and together raised after summation, together raised to the power of 5. All right, so to differentiate this one, consider this as a u. Okay, what do we have here? U to the power of 5. The inner function is u. So in such case, what can you say? You differentiate this one with respect to u.
yeah.
Okay, You will get 5 into, you will get 5 u to the power of 4. Okay, but this is not what is given. You consider this as a u. But eventually you need to find the differentiation with respect to x. Differentiation with respect to x. Okay, so this is dy by du, and you have to find du by dx also. What is du? What is u here? 3x plus 2. Differentiate this with respect to x. You'll get a 3.
Yeah.
Isn't it? 3. Okay, so when you put this, multiply these two together, you will get the differentiation of 5 with respect to x. Okay, dy by du multiplied by du by dx, you will get it dy by dx. Du gets cancelled and you will get it dy by dx. What is dy by du? This one. What is du by dx? Is this one. What is u here? This one you consider as a u. You keep that as a u. Okay, it's a bit confusing, but the way you have to differentiate when such kind of functions are given is that x to the power of n, dy by dx. First inside, so bring the power as a multiplier, reduce the power by 1.
4.
What do you get when you reduce the power? 4. Okay,
Yeah.
and then you have to find the differentiation of the inner function. 3. Okay, 3. So when you club everything,
Oh yeah, it is the same thing as the previous.
yeah, the same thing what we
Yeah,
got
yeah.
here. Yeah. Okay, the 5.
Yeah.
Power has come here. 3x plus 2. Power is reduced by 1. Multiplied with the differentiation of 3x plus 2. Okay, so when you simplify, how can we further simplify? 5 times 3, 15. 3x plus 2, 4 to the power of 4. Okay, there's no need to expand it because it's so big, so it's difficult to expand it. If you want to expand, you can do it, but you can leave it like
Yeah,
this.
but we can differentiate that part.
This part.
Yeah.
After differentiation only, we got this one. Why you
Yeah,
want to
but
differentiate?
we can like say simplify, right? Like
The only way to simplify is to expand this one. A plus b whole to the power of 4. This is a, this is b whole to the power of 4. Use either Pascal triangle or binomial expansion. But there is no point in that. Is not the question he asked. Yeah.
Why did you multiply it by 3?
Because the differentiation of 3x plus 2. What is differentiation of 3x plus 2 with respect to x? Is 3.
Why do you have to do it that way?
See, the power has come here.
Yeah.
3x plus 2 as it is.
Yeah.
Power is reduced by 4.
Yeah.
Is that all? No.
Yeah.
Multiplied by, what is the inner function here? 3x plus 2.
Oh.
You need to differentiate that and multiply the whole answer. What is the differentiation of 3x plus 2?
3.
3. Multiplied with 3.
So basically, first the 5 times 3x plus 2 whole to the power of 4. That is a differentiation of the whole thing. And
That is
the
not the
3
whole
is-
thing, but this is called the chain rule. You differentiate this, consider this as one variable and differentiate it. 5, this variable here, the power is reduced by 1, multiplied by. Differentiate this one, whatever you consider as a variable, you differentiate it again with respect to x. You got 3. Okay, 15 times 3x plus 2 whole to the power of 4. Okay, there can be tricky questions asked in this space. Those questions can be something like y is equal to 5th root of 3x plus 2. How can we answer this? How can we
Square. No, 1 by 3x plus 2 whole to the power of 5.
No,
3x plus 2, that can be written as 3x plus 2 whole to the power of 1 by 5.
exactly, that is right. Yeah, okay. This is not equal to 1 by x to the power of 5. Only when there is a negative power, then it becomes a fraction.
Yeah.
Okay, so if it is like this, 5th root of x is x to the power of 1 by 5.
Yeah.
Okay, don't mix up and mess up. Practice more and more. What is x to the power of minus 10? 1 by x to the power of n. What is x to the power of a by b?
B root x
Bth
to
root.
the power
Okay.
of a.
It's not a multiplier, it's a bth root. Okay. To make it clear, you need to clearly write such a way that this b is completely under root within this v shape. Otherwise, if you write b times x to the power of a, it gives a lot of different meaning. Totally different meaning because b multiplied with x to the power of a. Okay, to avoid this confusion, keep this one a bigger one and keep a b here. Okay, alright. So this can be written as 3x plus 2 whole to the power of 1 by 5. Y is this one. How do we differentiate? Again, the same chain rule we need to apply. Pick this as a some variable here and differentiate that variable with respect to that variable first. Dy by dx is equal to. So when you differentiate this one, what do you get? Get up.
1 by 5 times
1 by 5 times 3x plus 2.
2.
Power is reduced
1
by
by
1.
5 minus 1.
1 by 5 minus 1 minus 4 by 5.
Minus 4 by 5.
And then, is that all?
No, you have to differentiate.
Multiply with the differentiate this one with respect to x. So you'll get a 3. Okay. Simplify this. How can we simplify? 3 times 1 by 5.
3 times 1 by 3 by 5.
3 by 5. 3x plus 2 whole to the power of minus 4 by 5. Okay. This can be further simplified. How can we do that? Tell me. There is a negative power here.
Expansion.
No.
Yeah.
Negative power.
So it is 1 by
1
1
by
by
3x plus 2 to the whole to the power of 4 by 5.
4 by 5. Okay. This can be written as
for 5 multiplied by.
no
Yeah,
by 5.
Oh,
So this
fifth
goes
root of
fifth root of. Okay.
No, wait. And we will do this way like 3 by 5 multiplied by
Yeah, we can do that. Yeah.
that one and then 3x plus 2.
Yeah, we can do that as well. Yeah, it won't make any difference. So this numerators are getting multiplied and denominators gets multiplied. There is no difference. Okay. All right. This chain rule is important again. Okay. So what is the differentiation of 1 by x? Y is equal to 1 by x. What is the differentiation of x with differentiation of y with respect to x? Again, bring it in base and power form.
X.
How can we bring it?
To the power of minus 1.
X to the power of minus 1. So the differentiation is.
Minus 1.
Sorry, this is not that. Y is equal to x to the power of minus 1. Okay, we are not differentiating. We haven't started differentiating yet. Y is equal to x to the power of minus 1. So dy by dx is equal to
minus 1 times
minus 1 times x to the power of minus 1 reduced by
minus 1 minus 2.
minus 2. Okay. So this is my. How can we write minus 2? Quickly.
1
Minus
by x to the
1.
power of 2. 1 x by
1 by x to the power of 2.
Yeah.
Which is
1 by square root of 2. No.
1 by x to the power of 2. So
Write it.
x square. That's it. Isn't it? 1 by x to the power of 2 minus 1 by x square. Okay. Okay. There is also another formula. Okay, the division rule or something we call it as, I don't know what we call it, but yeah, this is how it goes. For example, y is equal to u by v. In such case, dy by dx is equal to v, remember this, v du by dx minus u dv by dx with respect to by v square. Okay, the v starts with v multiplied by, differentiate this one minus this one, differentiate this one with respect to x by v square. Give some example in this form.
3 by. Oh, no, wait.
Yeah.
Like what type of example?
Give any example, give any expression having this form.
Oh. speed equals distance by time.
Hmm?
Speed equals distance by time.
No. Okay. Okay, that's a distance by time, correct. But give some expression. Give some expression in this form.
2x minus 3 by 5 by 2.
3x minus 2?
3x minus 2 by 5x minus 3.
Exactly, super, yeah. That can be considered as an example. Okay, let's pick that one. Say that again, y is equal to?
3x minus 2 by 5x minus 3.
5x minus 3. Okay, there is no shortcut here because there is no x and there is no fixed x and there is no power for it. This is where you need to apply. What is u here? 3x minus 2. What is v here?
Yeah, but can it be like 3x I for 4 over x?
3x by 4x, x gets cancelled, 3 by 4. Who's calling?
Oh, okay.
Okay. Here there is no simple way to cancel it. There is no fixed x terms here. Okay, this is where you need to apply. Okay, can you read out this one? Well, can you read out this formula?
V times differentiation of u with respect to x minus u times differentiation of v with respect to x over v squared.
Over v squared. Okay, now without looking at it.
V times
Y is equal to u by v.
v times differentiation of u with respect to x times u times
Minus
u times differentiation of v with respect to x over v squared.
Okay. Alright. So what is u here? When you pick this example?
That
3x
whole-
minus 2.
Yeah.
What is v here?
5x.
Okay. So dy by dx is equal to, denominator comes first, 5x minus 3, and differentiation of this with respect to x. What is differentiation of this with respect to x? Should be able to tell.
3.
3. Okay?
Yeah.
3.
Yeah.
X differentiation is 1. 3.
Times
This is
3.
0. 3. Yeah.
Times 3
3 minus
minus 5x minus 3. No, 3x minus 2.
3x minus 2
Times 5.
Into 5
into 5
by
by
5x minus 3 whole
5x minus 3 whole square.
whole square. Now you simplify it. How can you simplify it? Say that. Simplify.
15x minus
15x
9.
minus
9
minus 15x minus 10.
minus 10 under bracket.
Yeah.
Okay. Again, if you
Yeah.
open the bracket, this symbols will change. Here minus,
And there plus.
there will be plus by 5x 5x minus 3 whole square. So how can you simplify this one? 15x minus 15x
Gets cancelled.
0.
gets cancelled, and plus 10 minus 9.
1
1 by 5x minus 3 whole square. That is the answer.
Or we can. Okay.
Yeah. We can leave it like that. Yeah. Okay. Yeah. Even the complex functions can be given. Something like 2x square plus 3 divided by 5x minus 2. Okay. What is the formula for? How can we do this? V with the differentiation of this one with respect to x.
Minus u with the. I don't know how to say.
Okay, let's take one complex example. Because the division rule and the chain rule both we
Wait,
have to apply at a
I have a
time.
question. Is that formula used to differentiate fraction expressions? Like u by v?
No.
Which one?
That
no.
formula
Oh.
is used to differentiate fractions, right?
No, but
Fractions.
even
Fractions that
though
cannot
it
be
will
simplified.
easy.
For example,
You're right.
5x square by x is also a fraction. But this can be this can be simplified easily. You get 5x.
Yeah.
Which can be differentiated easily. For example, if it is something like this, 2x plus 3, there is no way to simplify it. So this is a proper fraction form.
Yeah.
Having
What if there is no 3, like even though it will.
even though we have to apply the same rule.
Yeah.
What if it is a 3 here? What if it is a 5 here?
5. Yeah.
You can bring 1 by 5. This one. 5 is a denominator.
Oh, yeah.
You can bring 1 by 5 and this is 3x plus 2. you just bring this aside and just differentiate it.
Yeah.
Okay. Okay, now I'm giving you an example where you have to apply both a chain rule and a division rule. Something like this. 5x plus 2 whole cube by 3x plus 2. Y is equal to 5x plus 2 whole cube over 3x plus 2.
First, differentiate the numerator. 5x plus 2 over 3.
First of all, this is u by v form. That is one thing.
Oh no!
And
First, say
Do the-
simplify the upper
how
part.
can we simplify
No,
this?
no, it's like through.
differentiation.
Yeah.
Through expansion.
No, through the.
Very good. Yeah.
That's
Okay.
what I said.
Okay, say I'm taking, because name is Dharani, I'm taking D. D is equal to 5x plus 2 whole cube. I'm differentiating this dd by dx. Okay, dd by dx. Doesn't look good, right? So I'll take it as a t. Okay. dt by dx. So when you differentiate this one, you will get 3
Oh no! I actually typed it as V.
v. Yeah.
Yeah.
No, I'll take it as u then. du by dx. Okay. Alright, yeah. So let's differentiate it with respect to x. We get 3. The power is reduced by 2. Is that it?
No.
Is that it?
Multiplied by
Multiplied
5.
Multiplied by 5. So when you simplify it, you will get 15 5x plus 2 whole square. Okay, so this is a differentiation. Now, coming back to here, dy by dx is equal to v 3x plus 2 differentiation of this one with respect to x. What is that?
5. No, wait.
We did it separately here.
Yeah.
There.
Denominator
Oh, yeah.
first.
Okay.
Differentiation of this one. What is the differentiation of this one?
That
Thing. Because we had to apply the chain rule here. For the numerator, you need to apply the chain rule
Wait,
here.
that's the formula that we.
That we did.
Okay.
U by v formula.
Okay.
V differentiation of
15 5x plus 2 whole squared
15 5x plus 2 whole square
minus
minus
5x that whole
5x plus 2
is 2 whole to the
whole cube and differentiation
times
of this one
3.
3
times 3
times 3 divided by over
v squared
v square. What is v square?
3x plus 2 whole squared.
Whole square. Okay, sorry, v square. Yeah, correct. Yeah, so how can we further simplify? There's not much we can do here, but you can keep a 15 to the front. Okay, bring to the front 15 3x plus 2 5x plus 2 whole square minus 3. You can keep it ahead. What is the need for doing it like that? Because this is a constant multiplier, so you bring it to front.
Yeah, and then simplify.
No need to
Oh, no,
simplify.
no,
You
it's
can
okay,
leave it
it's
like that.
we
Simplification, like
can
expansion, will
actually.
give bring them.
Yeah.
Oh yeah, if you want, you can. Yeah, this is only a place where you can do a bit of simplification. But no point in expanding this because expansion will give
It's
you
very
more
long.
terms,
It's very long.
and will become a very lengthy. Okay.
Yeah.
Before we wrap it up, sine theta differentiation is what?
Tan theta.
No, cos theta.
Cos theta.
Yeah.
Sine theta differentiation is cos theta. Y is equal to sine theta. What are we differentiating with respect to?
Cos.
No?
No,
Theta.
Theta. With respect to theta. The variable here is theta. dy by d theta is equal to cos theta. Okay? Say for example, here I have a 5 theta. Okay, again, what is the differentiation of sine theta with respect to theta?
Cos theta.
Okay. What is, no,
Okay.
with respect to theta. What is the differentiation of cos theta with respect to theta?
Sine theta.
Minus sine theta. Okay, there's a bit of difference. Okay, these two just by hearted. Okay, what is the differentiation of sine theta?
Cos theta.
Cos theta. What is the differentiation of cos theta?
Minus sin theta.
Minus sine theta. Okay, when I don't say anything explicitly, that it always means a differentiation with respect to theta because the only one variable there is theta.
Theta.
Okay. Alright. Say for example, I put sine theta here. Y is equal to sine theta. What is the differentiation of y with respect to theta? What is the sine theta differentiation?
5.
What is
Fi-
this sine theta differentiation?
5 cos theta?
No. What
Oh,
is the
no.
difference?
Cos theta.
Cos phi theta.
Cos phi.
Okay.
Because phi theta is there. And then what is the inner function phi theta? Differentiate phi theta again with respect to theta.
5.
5.
5. You got 5.
Oh.
Okay. So
Is
in this
5
case-
cos theta not the same as cos 5 theta?
No, it's
No,
not.
it's totally
No, it's
different.
not.
Okay.
Okay. For example, sine 2 into 30.
40.
What does it mean? Sine 60.
Yeah.
Okay. Sine 60, which is less than 1. Sine value always lies between -1 and +1. Say if I say sine 30 2 multiplied with sine theta. What is sine 30? Sorry, sine 30. What is sine 30 value? 30 degrees, sine 30 degrees, what is it?
1 by 2?
1 by 2. 2 multiplied with 1 by 2, you'll get 1.
Yeah.
Alright, yeah, it's not the same. Okay, knowing those differences is quite important before we start doing anything. Okay, yeah. Okay, now 5, you bring it aside. 5 cos phi theta. Okay, the chain rule is applied here also. Not only in the expressions having x, but there are also expressions having trigonometric functions.
Yeah.
There also you need to apply the chain rule. Okay, for example, sin theta by cos theta. What is the tan theta? Sin theta by tan, cos theta is tan theta. If somebody asks you what is the differentiation of tan theta with respect to theta, you forgot the formula. There might be some
Tan.
no. Y is equal to tan theta. Okay, you forgot the answer. You don't know the differentiation of tan theta with respect to theta. The way you can write it, but you know the differentiation of sin theta and cos theta.
Yeah, but if you find.
Oh, is it cos theta divided by
Sin
minus
theta by
sin
cos
theta?
theta. You write it tan theta is sin theta by cos theta and apply the division rule. The same thing. V into
Oh, okay.
dy by
Yeah, is there.
d theta is equal to cos theta. Differentiation of sin theta. What is
Minus
this?
cos theta times
Cos
cos theta
Minus
sin theta minus sin theta
minus sin theta
divided by
divided by
cos theta whole squared.
cos square theta.
Cos squared.
Cos theta whole square or cos square theta both are same. Okay. Again, that is also.
Yeah, but
No,
I have a
isn't.
doubt.
Hmm.
What if the theta is for 5? So no wait. Or if it is 5 where theta equal to 5,
Okay.
then cos square 5, how can it be? It should be like cos 5 whole square. It should be like.
No, it can be written like this also.
Yeah, but squaring only cos, right?
No, when
It
you say
isn't
cos
squaring.
square phi, find the value of cos phi and the square it. What is the value of cos phi? Is it a constant?
0.
No, it is. It's not 0. Suddenly, it's not 0.
Yeah.
It's having some constant and square that constant. Cos phi is some constant, isn't it?
Yeah.
How do you find the cos phi value?
Through the.
No, through calculator.
Oh, okay.
Through calculator. Okay. Yeah. All right. So, what is here? Cos square. How can you simplify it here? Cos square theta
Minus
plus
plus sin square theta
by
cos square theta.
cos square theta, which can be written as
1 by cos square theta.
How can we write it? This one?
Sin square theta plus cos square theta is 1.
Sin square theta plus very good.
Is one.
Super.
1
1
by
by
cos square theta.
theta, which can be written as 1 by cos theta. What is it?
Or is the sine.
No.
Not tan.
No,
Oh, square root of
secant.
no, secant.
Yeah,
Secant theta.
secant.
So if it comes up,
It go secant.
secant square theta.
secant square theta. Okay, that is the answer. Tan theta, the differentiation is secant square. Okay, if you remember, that is fine. If you don't remember, this is how you can apply it.
Okay.
What rule is this?
The chain rule.
No, division rule.
Division rule.
U by V is a division rule, and this is called a chain rule.
Chain rule.
Okay,
Chain rule is just simple.
simple. Yeah, just to find out the Consider
But
the
then-
whole thing as an inner function. Differentiate it first and then differentiate the inner function.
But then
again.
this division is formula.
Division is the formula. V differentiation of this one with respect to x minus u with respect to v by v square. Alright? Okay. Leave it here. Differentiation is very important concept. Alright? Okay. We will meet some other time. Thank you. Bye.